Hi everyone. This presentation is on vectors in the coordinate plane. We can also refer to it as the y, xy plane. Um, so let's get started. Vectors in the coordinate plane. Look at figure 1. We have a vector OP, and this vector is in standard position. That means the tail of the vector is on the origin, as you see. Now, the coordinates x comma y will indicate two components. So the x will indicate the value of the x component, and the y will indicate the value of the y component. We know that every vector has two components, one horizontal, one vertical. And those two components will have the magnitude and a direction. For instance, if I have this vector, then the x component is negative, the y component is positive. This negative will indicate that the direction is negative, and the positive indicates that the direction is positive. And the value will tell us the magnitude or the absolute value of the that value would indicate the magnitude. So let's go over the formal definition. A vector OP, this is a vector OP, in standard position on a rectangular coordinate system can be uniquely described by the coordinates of its terminal point P x comma y. So we do not OP on the coordinate plane by um, x comma y, and as you see, that's called the angular um, bracket. The angular bracket. So let me make it clear. It looks like this angular bracket. Okay. All right. Note that x and y are the rectangular components of OP. Therefore, x comma y is called the component form of the vector. So that's the component form of the vector, meaning if we're given a vector in this form, v equals x comma y, then we know this is the x component and that's the y component of this vector. All right. We're still talking about the component form of a vector. So the vector form, the component form of a vector, AB, with initial point A and terminal point B. So now the difference between this one and the previous really no much except the initial point here, the initial point of this vector here is 0 comma 0, and for that reason we can ignore it because we know that y minus 0, if we try to find the difference between the terminal point and the initial point. So y minus 0, that's y, and x minus 0 is x. That's why we just go by x comma y. But if the initial point is not on the origin, then of course we have to calculate. Then to determine the vertical length, we have to do y2 minus y1. So this point here would be would have, well, let me not confuse you with this. So let's keep it simple. So y2 minus y1, that will give you the vertical length, and x2 minus x1 will give you the horizontal length. So actually, let me show you this. So this is x2 comma y1. Okay, x2 comma y1, this point. So if you want to find the vertical, it's y2 minus y1. The horizontal, x2 minus x1. There you go. All right. This is in case we're given the coordinates of the initial point and the coordinates of the terminal point. This is how we find the value of each component, the x component and the y component. Here's an example. Find the component form of vector AB with initial point A equals negative 4 comma 2 and terminal point B 3 comma negative 5. We don't need the graphical representation, but we can have an approximation. So an approximate um, value, I mean the points. So negative 4 comma 2. So let's estimate this is negative 4, and then this is comma 2. So that's point A. And then this is 3, negative 5. So 1, 2, 3, 1, 2, 3, 4, 5. So these are the 2 points. Negative 4, comma 2, 3, comma negative 5. And then to find the x and the y components, then what you have to do, we have to do negative 5 minus 2 and 3 minus 4. So what you're going to do. So vector AB equals negative 5 minus 2, comma 3 minus 4. Negative 5 minus 2, negative 7, negative 3 plus 4, that's a 1. And this, so the negative 7 will be the x component of this vector, and the 1 is the y component of this vector. And we call this is the component form of vector AB. Good. Let's go to the next one. Number 3, magnitude of a vector in a coordinate plane. So really, when we try to find the magnitude in a coordinate plane, it is not different than the concept of magnitude that we previously learned. What do I mean by that? The magnitude would be the length of the vector. So let's example this vector on xy plane, vector v. The magnitude will be the length. How do I find the length? Well, if I know the x component and the y component, I can simply use Pythagorean theorem. So it would be v squared equals x squared plus y squared, and then isolate v. Or if I have the coordinates of the point, the initial point of the vector, and the coordinates of the terminal point of the vector, then I can simply use the distance formula. All right, I use Pythagorean theorem if I have the x component, y component, and so on. So most of the time we just use the distance formula. So what does the distance formula say? So v equals the square root of x2 minus x1. So distance between initial point and terminal point, plus y2 minus y1 squared. Now, it is also correct to say x1 minus x2, y1 minus y2. Because it is squared, then it won't make any difference whether you do x2 minus x1 or x1 minus x2. So we can use this, which is a distance formula, to find the magnitude of a vector in the coordinate plane, given the coordinates of the initial point and terminal point. We can also use Pythagorean theorem. If we're directly given a vector, this note over here, if a vector v has component form of AB, or if we're directly given the vector in its component form with the values of A and B, then we can go ahead and um, use the Pythagorean theorem, which says, let me make a rough sketch. A, B, this is V. So Pythagorean theorem, which says V squared equals A squared plus B squared. So V, or if you want the which the magnitude V is square root of A squared plus B squared. Okay, so let's work on example 2. Find the magnitude of vector AB with initial point negative 4 comma 2 and terminal point 3 comma negative 5. We can go ahead and use directly the distance formula over here. So AB magnitude of vector AB would be square root of, let's do 3 minus negative 4 squared plus negative 5 minus 2 squared. Let's calculate 3 plus 4, 7, 40. So squared is 49. And then negative 5, negative 2, negative 7 squared for another 49. 49 plus 49, that should be 98. We can keep it like this, or we can find its decimal approximation. We'll get a little bit as square root of 98. Let me see if we can simplify square root of 98. No, we can't. Square root of 98, that cannot be simplified. Actually, it can. It can. Sorry. It's It's 7 root 2. So it's either 7 root 2, or you just give the decimal approximation to this. Find the magnitude of the following vector. So now the vector is given in its component form. So we just go ahead and use the formula it says, or Pythagorean theorem. Magnitude of V is 3 squared plus negative 2 squared. 9 plus 4. 9 plus 4, 13. We'll leave it like that, root 13. Vectors operations. Once we see the words operations, so we normally talk about addition, subtraction, multiplication, things like that. So vector operations means how do we add two vectors, but not graphically this time, two vectors in their component form, for example. How do we add them? How do we subtract them? How do we multiply a vector by a scalar? There are more operations than just the addition, subtraction, and multiplication by scalar, but we're going to cover only these three. So let's say we're given vector A with its x component A1 and the y component A2. And same for vector B, x component B1 and y component B2. And also, let's say we have a scalar case, some number. Then the following are true. So how do we add these two vectors? Let's start with the addition. Adding these two vectors. So to add these two vectors, what we have to do is we add the x component to the x component, which would be a1 plus b1, and then we add the y component to the y component, which is a2 plus b2. As simple as this. So you add the x to the x, the y to the y. Good. If we do subtraction, same idea. So if we do subtraction, same idea. So we do a1 minus b1 and a2 minus b2. Good. Now, if we multiply a vector by a scalar, all we have to do is multiply the x component by that scalar and the y component by the same scalar, which means k a1 because now I'm multiplying k by a. And then k a2, sorry, k a2. So you multiply that number. It's kind of distributing. Let's look at it this way. Same concept as distribution. Right? Good. Let's work on this example. This example says find the following for w equals negative 4 comma 1, y equals 2 5, and z equals negative 3 0. The question says evaluate 2 times w plus 4 times y minus z. 2 is a scalar. So we got 2 multiplied by the x and y components of vector w. And then you got 4 multiplied by the x and y components of vector 5, and then minus z. So here what we're going to do. We're going to write 2 times w. W is negative 4, comma 1, plus 4 times y, y is 2 comma 5, minus z, which is negative 3 comma 0. Now, what we have to do is first distribute the 2. So this vector becomes negative 8, 2 times negative 4. 2 times 1 is 2, plus 4 times 2, 8. 4 times 5, 20. And then finally minus negative 3 comma 0. Okay. So now we have to add negative 8 plus 8, that's 0, minus 3, that's plus 3, so we got positive 3 so far. I'm going to repeat, minus 8 plus 8, that's 0, minus 3, that's plus 3. Good. 2 plus 20, 22. 22 minus 0, still 22. Good. So that's the resulting vector by adding this 3 vectors. Good. Next concept is unit vectors. So what is a unit vector? A unit vector is a vector that has a magnitude of 1 unit. It is sometimes called direction vector. Let's look at this concept in a bit more details. Let's say, for instance, we have some vector v whose horizontal component is 3 units. So it's a 1, 2, 1, 2, 3. So 3 units. And its vertical component is 4 units. 1, 2, 3, 4. And this is the horizontal. So 3, 4. And then here's the vector v. Now, what's the magnitude of vector v? Well, if we use Pythagorean theorem, we know that 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. So the vector v magnitude is 5 units. Now, if we would like to find a unit vector of a vector v, so what we're going to do, we're going to divide the length of the vector by 5. So it's going to be 1, 2, 3, 4, 5. So normally the vector v is written as x comma y, the x component and the y component. So if we divide this vector by the magnitude, which is 5, so if I divide the left side by the magnitude of v, well, I have to do the same thing to the right side. So I divide that also by the magnitude v. This applies to this figure over here. So because I divided this vector by 5, I should also divide the horizontal component by 5. So 3 divided by 5, and then the vertical component also by 5. So 4 divided by 5. So this will This will lead to unit vector. Let's call it u. Let's suppose that v over the magnitude of v is u. We can put a hat there to indicate that this is a unit vector. If we don't, that's okay. So that would be x over the magnitude of v, comma, y over the magnitude of v. And we can do this because the magnitude of v is a scalar. This is the same as saying we're multiplying the vector v by 1 over some number, which is the magnitude of v. Let's say the magnitude of v is 2. So it means we're multiplying, dividing x comma y by 2 is the same as multiplying x comma y by 1/2. So it is similar to scalar multiplication, which is the same as 1/2 times vector v. So again, to find the unit vector, you pretty much have to divide the x and the y components of that vector by the magnitude of the vector. Here's the formula over there. So let's work on example 4. Example 4 says find the unit vector u with the same direction as v with the x component -2 and the y component 3, then find its magnitude. So let's find the unit vector. Now, we said the unit vector u is v divided by the magnitude of v. What is v? V is -2, comma 3. What is the magnitude of v? Well, that's a square root of -2 squared plus 3 squared. So -2 comma 3 divided by 4, -2 squared is 4 plus 9, that's 13, root 13. So 4 plus 9, that's root 13. Now we can go further and write it as -2 over root 13, comma 3 over root 13. Now the question says find the unit vector u. We found it. That's the unit vector u, and then find its magnitude. So we can keep this like this, or we can rationalize. Either way, depends on the question what it requires. We can keep it like this, or we can rationalize. Now let's put this inside the box. That's the unit vector. Now, the next question says find its magnitude. Actually, the magnitude of a unit vector is 1. This is more of verification whether our work is correct. So that means when we find the magnitude of the unit vector is we need to end up with a 1. So magnitude of vector u is the square root of -2 over root 13 squared plus 3 over root 13 squared. That is 4 over 13 plus 9 over 13. And what is 4 plus 9? That's 13. Common denominator, 13. Square root of 13 over 13, which is square root of 1, which is 1. And that verifies that this is indeed a unit vector, because the definition of unit vector is a vector that has a magnitude of 1 unit. Same over here. If we try to find the example I gave you over here to explain, if we try to find the unit vector for this vector, so the vector v, this is extra. Okay, so vector v, whose x component is 3, y component is 4. So the unit vector u, it would be v divided by the magnitude of v, which is 3 comma 4 divided by 3 squared plus 4 squared. This is going to be 9 plus 16. 25 root 25 is 5. So it's going to be 3 comma 4 over 5. And then you just put them under separate fractions. 3 over 5 comma 4 over 5. And then if you want to verify that the magnitude of this factor is 1, you can do the same thing we did over here. Now let's look at the direction angle of a vector. So the direction angle of a vector, say vector v, let's look at this figure over here. The direction angle is the angle that the vector makes with the x-axis. So it is the angle that the vector makes with the x-axis. Okay. Now, this vector has component A and component B. A, which is the x component, so it would be magnitude of v times cosine of theta is A. And the component B would be the vertical component. So A is the horizontal component, B is the vertical component. So magnitude of v times sine theta, that's B. Now, to find angle theta, we can use trig functions. We can use tangent function. What do we know about tangent of theta? Tangent of theta is the opposite of adjacent, which is b over a. Opposite of adjacent, which is b over a. And what is theta? Theta is the tangent inverse of b over a. So we can use this formula to find the angle of direction theta. All right, example 5. Find the components form of the vector v with magnitude 10 and direction angle 120. So in other words, we want to write the vector v as a comma b. This is what we're looking for. So we need a and b. A is the x component and b is the y component. So this vector has a magnitude of 10 and a direction angle 120. So let's make a figure for it. So I assume this is going to be the vector. This is 120 and 10 is the magnitude of the vector. All right, 10 is the magnitude of the vector. Okay, good. So how do we find A and B? Well, we know that cosine of 120, it would be, sorry, let me take you back to review something first. So to find the x component and the y component, what you pretty much have to do, if we write cosine of theta, it would be a over the magnitude of v. So that means a equals the magnitude of v times cosine theta, as you see it over here in red. Same with sine of theta is b over, so the opposite, which is b divided by the magnitude of v. So that means b equals the magnitude of v times sine of theta. So I'm going to apply the formula directly over here. All right, so we're going to write a, which is the horizontal component, equals the magnitude of v which is 10 times cosine 120. And then b is the magnitude of v, which is 10 times sine of 120. This is the x component, horizontal component a, and the vertical component is b. Of course, we can simplify this. What is cosine 120? Cosine 120 is the negative of cosine of 60, which is 1/2. So 10 times 1/2. I mean, sorry, negative 1/2. We said the negative. So it's -5. Okay, so far a is -5. And then b, 10 times sine 120, which is the same as sine 60, which is √3/2, which is 5/3. So this will be 5/3. And with this, we have answered the question. The components of vector v are -5, 5/3. Okay. Let's work on example B. Find the direction angle of each vector to the nearest tenth of a degree. So we have to use most likely calculator here. So we said this is A and that's B. So tangent of some angle theta is the opposite because let's make a figure for this. 4, 1, 2, 3, 4. That's the x component. The y component is -5. 1, 2, 3, 4, 5. So it will be somewhere here. This is the vector. So the angle we're looking for is this one. Got to be the positive angle. So we know that tangent theta equals the opposite, which is here -5. This is -5. And the adjacent is 4. 4 units, -5 units. So tangent of theta is -5 over 4. But this will give us this theta, this one. And then we're going to, let's actually call this theta prime. That's better. And then our theta we're looking for would be that one. And let's use different colors so we don't get confused. So this is theta, and the other one is theta prime. So tangent of theta prime is -5 over 4, which now makes more sense. So theta prime, which is in green. So theta prime, so theta prime is tangent inverse of -5 over 4. And we can calculate that. We gotta be set the unit to degrees because it says here, find the direction angle of each vector to the nearest tenth of a degree. So it means you go to your calculator, you go to mode and make sure you set it to degree unit. All right, after that we can calculate. So we're doing inverse tangent, or tangent inverse of -5 divided by 4, and that's -51.340. That should be sufficient, but it says to the nearest tenth of a degree. We should do that for the final answer because we haven't found theta yet. So now theta, which is in yellow, that should be 360 degrees minus 51.340. It's the 360, the entire circle, minus theta prime. What's left is yellow, yellow angle, which is theta. So um, let's do that. So we got 300 is at the nearest tenth of a degree, so 308.65, so that should be 7. That's the angle theta. This is going to be our answer for this question. Okay, let's do the other one. Let's make a graph also, so it will make more sense. -3, 1, 2, 3, and then -8, 1, 2, 3, 4, 5, 6, 7, 8. So it's on quadrant 3. Our angle, the one we're looking for, is yellow again. This is the angle we're looking for, right? The angle we're going to find using tangent or inverse tangent, it would be this one here. It'll be that one. Let's see what happens. All right. So now we're going to use the same idea. This one here is -8. This one here is -3. So we know that tangent of, let's call this one theta prime, and the yellow one theta. Same as the previous one. So this is theta, and the other one is theta prime. I can barely see the prime, so theta prime. All right. Tangent theta prime is opposite over adjacent, -8 over -3. So theta prime is tangent inverse of 8 over 3. The minuses, they cross out. So let's do that. So we're going to do tangent inverse of 8 over 3. And that's 69.444 around. And then what I'm going to do, I'm going to calculate theta. What is theta now? Theta would be 180 minus 180 degrees. No, sorry, 180 degrees plus this angle. So 180 plus this angle. So it's 180 plus 69.444, which is 249.4. So that's 249.4. And with this, we have found the direction angle for example B as well. So 249.4 degrees. Last two problems, we got two application problems. Problem number 1, it says a quarterback running forward at 5 meters per second. So we're talking about the velocity of this person who is running forward. Quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second. So he is running at a velocity of 5 meters per second, and then while he's running, he throws a ball at the velocity of 25 meters per second. So it means the ball has a velocity, and the person is also has a velocity of 5 miles per second. So what is the angle of the ball with the horizontal line? 40 degrees. Look at the figure, that tells you everything. What is the resultant speed and direction of the pass? So what this problem is saying is the quarterback is running forward at 5 meters per second. So it means the ball, before he throws it, the ball is also running at 5 meters per second. Now, when he throws the ball, now you got the 5 meters per second plus the new velocity, which is 25 meters per second, because it throws the ball at the velocity of 25 meters per second. So it means the 5 meters per second, that's plus the 25 meters per second. So how do we do this problem? It says what is the resultant speed and direction of the path. So we're going to break this down to make sure that everyone understands this. We're going to start with the velocity of the quarterback, the 5 meters per second, which would be this one over here. So this is the velocity, which is 5 meters per second. Right. This is horizontal because the player is running horizontally first. So if it's only horizontal, then it has no vertical component. The vertical component is 0. We can say, okay, it has vertical component, but it's 0. So it means only the horizontal component. Think of, for example, if you're trying to push something horizontally, then you are only applying, you're only causing the object to move horizontally. So same idea here. So if we call this vector, let's label it with letter Q, the quarterback. Okay, Q. So vector Q has horizontal component 5, vertical component 0. So we're done with that one. Now let's look at the other one. Let's look at this one. This is the velocity vector of the ball. This one here. Velocity vector of the ball. Okay. So let's draw it over here. Obviously, the velocity vector of the ball, it has a horizontal component. Let's call it X, and it has a vertical component. Let's call it Y. Right. Now, what's the magnitude of the velocity vector? Let's call it. This is the velocity vector, but it represents the velocity of the ball. So let's call it, or let's label it with B. Okay, B. So B, this is B, and it's how much? 25 meters per second. Okay. Now this angle is 40 degrees. Right. So we can determine that x equals 25, the magnitude, multiplied by cosine 40. This is the formula that we need to get used to it. And then the vertical component, it would be 25 times sine of 40 degrees. So if I write the vector b in component form, so it would be 25, the x component, which is 25 cosine 40, comma 25, this is a vertical component, 25 sine 40. Good. So now I get the both vectors in component form. Now, when we add these two vectors, because obviously the ball, it initially had the, or has the velocity of the quarterback and the velocity of the throw. So it means if we combine these two vectors, we're going to get the resulting vector. So the resulting vector R is the sum of these two vectors. So R, it would be 5 plus 25 cosine 40, comma, 0 plus 25 sine 40. Um, Now, this is the resultant vector in the component form. So we can simplify this and round it to, or we can keep it like this. We can keep it like this. So we just need to get rid of that 0. So 5 plus 25, 25 cosine 40, and then 25 sine 40. Okay. Um, the question says, what is the resultant speed and direction of the path? So the speed would be the magnitude. So speed. Let's work on it over here. So speed is the magnitude of the resultant vector. What is the magnitude? It would be x squared plus y squared. So 5 plus 25 cosine 40 squared plus 25 sine 40 squared. Now let's do some calculations. So we're going to do a square root of that and see what we got. So we got 5 plus 25 cosine 40, and then we square it, plus 25 sine 40 squared. So I got 29.008, just do 29. We rounded to one decimal, or three decimal places, sorry. So 29.009. Good. This is what should be meters per second, because this is the speed. Okay, meters per second. Good. Now for the angle of direction, we know that this is over here is x, and this is y. For the x component, y component. So we're going to use the formula which says tangent of theta is, oh, let's, you know the formula by now. Let's just write theta is tangent inverse to reduce some work, to save some time. So tangent inverse of 25 sine 40 over 5 plus 25 cosine 40. Okay. So we put this in the calculator and see what theta is. It shouldn't be a problem in terms of like we did before, theta prime and theta, because this is on quadrant 1. So we give us the answer directly on quadrant 1. Okay, so we're going to do tangent inverse of 25 sine 40 divided by 5 plus 25 cosine 40. Good. And it gave me the angle of 33.639. Good. So we found the angle, the new angle of direction, and the magnitude. So what does this really mean in terms of the vectors? See, if you look back over here, this, when you add two vectors, we added the horizontal component of the q vector to the horizontal component of the b vector. So when you add them, this vector plus this vector, what you do, you can translate this q vector so that the the tip will be attached to the tail. So you're going to have a long vector. So I'm going to represent this over here. So it's going to be vector q and then vector, the horizontal component of the other one. So it will be one long vector like this when you add them, when you add the horizontal components. Now, when you add the vertical of the q vector is 0. The vertical of the b vector is um, is 25 sine 40. So approximately this. So the resultant vector, remember, this is the tail attached to the tip. So the resultant vector should be connecting the two vectors from the tail to the tip, like this. Okay, that's the resultant vector. And the magnitude of this resultant vector, this is resultant vector, the magnitude would be the what we did over here in blue, and the angle, which is, we found that it's 33.639. Now look at the graph over here. We can do something similar. So pretty much what happened, we added the vector here. Okay, I don't want to mess it up. So it's approximately this. That's the new resultant vector, but I think hopefully this one is makes it clear. All right, let's move on to the last problem. Last problem, which is an airplane is flying 40 degrees northeast. So let's draw a figure. 40 degrees northeast. So if this is east and this is north and this is south and this is west, so 40 degrees northeast will be this. So this is the airplane. So the airplane is flying 40 degrees northeast with an airspeed of 310 knots. That's the magnitude. 310 knots. That's the magnitude, the speed of the airplane. This is in still air. Encounters, so let's use different color. Encounters a wind acting in the direction of 145 north of east. 145 north of east. So north of east, 145. So approximately this one. But I gotta be smaller because this is only 78 knots. So let's extend this one. So the picture will make more sense. Okay, so let's extend this one. That's 300, still, it's not drawn to scale. So 310, and the angle we said is 40 degrees. Let me make it clear. 310 is the magnitude. And then the wind, we said the angle is 145. This is 145. And the magnitude is 78. Right. Now, it says because of the wind, the airplane requires new ground speed and direction. What are they? So the wind will affect the speed of the airplane and it will affect the direction of the airplane. So the question is, says, okay, so what is the new speed? What is the new direction? So if we add geometrically, if we add these two vectors, just to have an idea, we're going to use parallelogram method. It would be, this is the resulting vector. It means this is the new direction. This is the new direction of the airplane. And the magnitude, we're going to have to find what that is. But this is the new direction. It's between 40 degrees and 90 degrees, somewhere in between, maybe 55, something like that. It will be this angle. I just don't want to put too many things in there. That's the new direction, and then the magnitude, we have to find it. So we don't want to do so much on the figure. Let's use the formulas that we already know. So let's start with the airplane vector. Let's call it P. Now, the airplane vector is the blue one. So it has a horizontal component. We can probably do it over here. So make sure that you don't get confused. So magnitude 310, and it has the horizontal component. No, let's use different color. Horizontal component and a vertical component. This is 40 degrees. So horizontal, it would be 310, the magnitude of the airplane vector, multiplied by cosine 40 degrees. The vertical component, 310 magnitude multiplied by sine of 40 degrees. Good. We got that. This is for the airplane. So this is the plane. Okay. Let's do the other one. Let's use different color for that one. The other one. Here's the vector. Now its horizontal component will be this one. The wind. This is W. The wind. The horizontal component will be this one. Vertical will be this one. This is what? 78 magnitude? Yes. Now, we can use directly 145. We don't have to find this small one. It works. So what you want to do is this. You do that idea goes back to trig. So if we need to review that, we can do that. Um, so it's going to be, for the horizontal component, it's going to be 78, which is the magnitude, multiplied by cosine of 145. And a vertical component is going to be 78 times sine 145. Good. Now the resultant vector is the sum of the x components of both vectors of each the sum of the x components of the vectors, comma, the sum of the y components of the vectors. So that means 310 cosine of 40 plus 78 cosine 145, comma, 310 sine 40 degrees plus 78 sine 145. Good. Now to find the magnitude of r, well, let's just put everything and then put everything in the calculator. So it will be 310 cosine 40 degrees plus, this is not clear, 310 cosine 40 plus 78 cosine 145 squared plus 310 sine 40 plus 78 sine 145. I hope I have no mistakes. And let's put that in the calculator to see what that is. So start with the first one, 310 cosine 40 plus 78 cosine 145, and that's squared plus 310 sine 40 plus 78 sine 145 square it equal. Okay, you got something that makes sense. 299.445. And this is knots. Good. Now we're going to do the same thing for the new angle, and I said the new angle should be in between 40 and 90. And let's see if that's correct. Okay, so theta is tangent inverse of the ratio of the y component, which is 310 sine 40 degrees plus 78 sine 145, all divided by 310 cosine of 40 plus 78 cosine of 145. Let me just verify that this is all correct, entered correctly. Yes, that looks good. All right, now let's put it in the calculator. We're going to do tangent inverse, and then we're going to do the fraction. So 310 sine 40, 310 sine 40 plus 78 sine 145, and then on the bottom I get 310 cosine 40 plus 78 cosine 145, cosine 145, close, enter, and I got something that makes sense. 54.573 degrees, which I said is between 40 and 90, and that's between 40 and 90. And this is the end of this question. Thank you for watching.